we can now continue. So in this session now, the second session, we're going to look at indices. Okay, so indices are very similar to algebra. Actually, you find some mathematical books will keep swapping these two topics, because the debate is which one should come first, indices or algebra. Because if you go to algebra, you are going to see powers there. Okay, you go to indices, you're going to see variables there and coefficients. So that is the dilemma that is there. So it is unclear which topic should be learned first or taught first, whether it's indices or algebra. But so now we're here. Okay, so under indices, we're going to look at a couple of laws of indices. And so our goal is to achieve the following. We're going to look at double indices, zero indices, fractional indices, negative indices, indicial equations, and exponential equations, and we should be good to go, such that whatever question the examiner can bring on indices, we'll be able to answer it. So indices also come, all the topics, all the subjects, all the topics we're going to cover throughout this crash course come in paper 1. Okay, so all the questions you are seeing here, I'm just picking different variations of the questions so that we can do a lot of variations that will prepare you to answer any question, because on each topic they'll bring just one question. Like for indices, they'll just bring you one question on indices. So we're doing different variations so that whatever variation they can bring, we would have covered it. Okay, so but before we start looking at these indices, let us start with an introduction. Remember the time we're looking at algebra, I did some form of early introduction to say when the power of a value is not indicated, it simply means that power is a 1. Okay, so actually all these counting numbers we know, 1, 2 up to whatever number you might want. 2 to the power 1 is just written as 2. Okay, x to the power 1 is just written as x. Just as we were saying the time we're looking at algebra, we said when the coefficient of a variable is 1, you don't write it. Instead of saying 1x, you just say x. Similarly, when it comes to indices, when the power of a value, okay, is 1, you don't write it. You just write down that value. That is how come 2 raised to the power of 1 is just written as 2. Okay, x raised to the power of 1 is just written as x. So that is that you have an invisible power of 1. So under the laws of indices, we are going to look at multiplication. So in this case, actually before we get to that, let's look at this. So you have 2x, and then you have let's say you have 5y squared. Not really, I'm still in algebra. Okay, you have x to the power of 2, and then let's say there you have 3 to the power of 4. Okay, so this one here, these powers, we already know they are called powers. They can also be called indices, or if it is one, index, plural indices. They can also be called exponents, especially when you go to university mathematics. The powers are called exponents. Okay, if you noticed in the previous slide, there was where it said exponential equations. Okay, so the power can be called an index, a power as we normally call them, or it can be called an exponent. All right, and then these numbers down here, like the x and the 3, these are called bases, or basically a base. So the x here is a base, and then the 2 is a power. Okay, you go to the other side, the 3 here is a base, the 4 is a power. I'll be using the word power since that's the one we're mostly used to. Sometimes I might say index. Okay, so that is that. When you have 2x squared, okay, 2 and x compose the base, and then remember we said when the power is not indicated, it means it's a 1. Okay, so we have a power there and we have another power there. Okay, so that is that. Then when it comes to indices, there's something I wanted to mention. Okay, so if you have 2 to the power 2, the power is basically a shortcut of the repeated multiplication of a number by itself. Okay, so 2 to the power 2, okay, let me use a different power, 3, because this one can be a bit confusing when explaining. 2 to the power 3 does not mean 2 times 3. It simply means 2 times 2 times 2. Remember I said the power is the repeated multiplication of a number by itself. So we are simply being told to say this 2 here is being multiplied by itself how many times? 3 times. So that is how we come, we have 2 times 2 times 2. That is what a power symbolizes. When you have 3 squared, the answer you should find should be a 9, not a 6. This does not mean 3 times 2. It simply means 3 times 3, which should give you a 9. So the power simply shows you how many times a number is being multiplied by itself. Please take note of that. Okay. We can now start looking at the laws of indices. So under the laws of indices, we are going to start with the first law, which is multiplication, which actually states that, so multiplication a to the power m times a to the power n is equal to a m plus n. What does this mean? In this case, the a's are representing the bases. Remember I said when you have something like this, 2 to the power, even x here, the 2 is a base and then the x is a power, right? So here the a is the base. So what we are assuming here is that when your bases are the same, you've noticed there's a here as a base, there's also a there as a base. When the bases are the same, all you have to do is you simply add the powers. The powers are represented by m and n. That's how come you have m plus n. This was the shortcut I showed you the time we were looking at algebra, where I said x squared times x cubed. I said when the variables are the same at that point. Okay, but now that we are looking at indices, allow me to say when the bases are the same, all you have to do is you add their powers. So we are going to say x is equal to 2 plus 3, giving us x to the power of 5 as our final answer. So that is the rule when it comes to indices. When the bases are the same, simply add their powers. Okay, that is the rule we use when we are dealing with multiplication. Therefore, if you add something like this, a to the power 2 times a to the power 3, what are you going to get? You've noted that the bases are the same. So all you have to do is write down the same base and then you add the powers. 2 plus 3, which is going to give you a to the power 5. Now, what about when you have numbers in front of those variables? Okay, let's say there's a 2 here and then there's a 3 here. Okay, let me write it properly. So times, you have a 3 there. How are you going to do it? So all you have to do, the first thing is multiply the numbers. 2 times 3, what does it give you? It gives you a 6. And then you apply that principle on the variables. So we are going to say a to the power 2 plus 3, which is going to give you 6a to the power 5 as your final answer. Okay, so that is that when it comes to multiplication. When actually, before you proceed, however, when you have different bases, let's say for example you have 2a squared times 2b, maybe squared even. The principle is the same. Multiply the numbers. 2 times 2 is a what? 4. Now these are different variables, right? Okay, so when they are different, just put them together. A squared, b squared. Remember, this only applies when the bases are the same or when the variables are the same. So now, how do you determine whether the bases are the same? You focus on the variables for this one as well. You focus on the variables. If the variables are the same, then you know to say the bases are the same. But here you notice that the variables are different. There's an a here, there's a b here, meaning these bases are different in as much as the coefficients are the same. Your focus, even here when you're looking at indices, the focus is on variables. Okay, I hope that is clear. We now proceed to the next rule, which is division. Okay, so division is the opposite of multiplication. When you are multiplying the same bases, you add the powers. When you are dividing, you subtract the powers. Okay, that is the principle we follow. So for division, let's say we have a to the power m divided by a to the power n. You will notice that the bases are the same because we have a there and a there serving as a base. Okay, when the bases are the same, all you have to do is subtract their powers, which is m minus what? N, because m and n here are representing powers. Therefore, if you had something like x to the power 3 divided by x to the power 2, what should you get as your final answer? It's going to be x3 minus 2. Final answer will be x raised to the power of what? 1. But remember, we said when the power of a value is 1, you don't write it. Okay, similarly, when you can't see the power, it simply means it is 1. Okay, so that is that. How about when you have something like this, x to the power 2 divided by x? What is going to be your answer? Okay, the variables are the same, right? So we subtract the powers, so meaning it's going to be 2 minus what? 1. Remember, we said if you can't see the power, you know it's a 1. Okay, so remember to apply it when it is necessary. Okay, so meaning your final answer there will just be x to the power of 1, but we said when the power of a value is 1, you don't write it, so we just write it as x. But when we are solving, you apply it. There's a 1 there, that's why we're doing 2 minus 1 there. So that is that for division. Okay, so at this point I've only introduced you to this type of division where you are subtracting from a bigger number. There are scenarios where you have something like x to the power 2 divided by x to the power 3. When you subtract these values, what are you going to do? You're going to say 2 minus 3. This will give you what? X to the power negative 1. Okay, so at a later stage we will now look at what this means. Okay, negative indices. So that is that under multiplication. Okay, let us look at some examples, some more examples on multiplication. Let's say now you have something like 20x squared divided by 4x. So you notice to say there's a number here, there's a number there. So the first thing you do is divide the numbers. 20 divided by 4 is a 5. Okay, then here the variables are the same. We said when you're dividing the same variables, you subtract their powers. So meaning it's going to be x to the power 2 minus a 1. There's a 1 here, remember. So your final answer will just be 5x, and you are done. Okay, how about when you have different variables? Okay, something like 20x to the power 4 y divided by 20, not really 20, but let's put a different number. Let's put 5. Okay, 5x maybe the power 2, just like that. What is going to be your answer there? So just going to say 20 divided by 5, it is a 4. Okay, there's an x here, there's an x there, so you apply the principle of same variables, you subtract the powers. But there's this y here with nothing to divide with here, so just indicate the y there. Okay, then 4 minus 2 there will give you 2, meaning that will be your final answer. So when you're multiplying or dividing different variables, you simply put them together at the end. That is the rule you are going to be following. Okay, I hope that is clear. We now proceed to double indices. Okay, what are double indices? Oops, we're almost running out of time on the other side. So Margaret, once the meeting ends, I'll quickly recreate another one. Okay, I have about 9 minutes 45 seconds, so just letting you know in advance, once the meeting ends, I'll quickly create another one and share the link with you, then you can quickly join back. Okay, so now we look at double indices. What are double indices? Double indices are basically scenarios where you have, let's say you have x the power 2 and then you have another power outside the bracket. They are called double indices because you have two powers there. Remember I said indices, they simply mean the same thing. It simply means a power, right? So these are called double indices because you have two indices there. Okay, so how do you handle double indices? All you have to do is multiply the indices. So it's going to be 2 times the 3 there. Okay, 2 times 3 there, giving you x to the power 6. That is what you do whenever you have double indices. Okay, if you have something like this, 2x squared, okay, the power of 3, how do you solve that one? Remember, this 2 is raised to the power of 1 as well. So I've seen students only applying the double index to the other number and leaving this one here. Okay, this 2 is also raised to the power of 1, so you have to apply it to the 2 as well. So meaning it's going to be 1 times the 3, which is outside there, and then the x will also be 2 times the 3 outside there, meaning what you get, you're going to say 2 to the power 3 x to the power 6. Okay, 2 times 3 is 6, 1 times 3 is that one there, which you can then simplify. 2 to the power 3 will give you 2 times 2 times 2. 2 times 2 is 4, times 2, that is 8, x to the power 6. Okay, these don't usually come this way. The examiners like bringing them in this format. They'll give you something like this. They'll say maybe 2 over 4, and then maybe to the power 2. Okay, what that simply means is that you have double indices here. Okay, there's a power here, there's also a power here. So how are you going to apply that one? You're going to say 2 to the power 1 times 2 there over 4 to the power 1 times 2. Okay, which will then give you what? 2 to the power 2, because 1 times 2 is 2, over 4 to the power 2, because 1 times 2 is 2 there. Then you simplify, 2 squared gives you a 4, 4 squared gives you 16, which you can simplify further actually. 4 into 4 there is 1, 4 into 16 is 4. So that's how examiners will usually give you double indices. Now there are these types of double indices they like. Let's say they'll do something like 2 to the power 3, like that, and then the index there is a negative. Okay, so the first thing you need to do is you convert that negative power to a positive. Okay, remember I said I'm giving you shortcuts here. So what is a shortcut? The shortcut is the values inside the brackets, simply flip them. The numerator becomes the denominator becomes the numerator, and then your power becomes a positive. So you notice the 3 here is a denominator, in this one it becomes a numerator. The 2 was a numerator, it becomes a denominator. So simply swap those values, and then the power becomes a positive. Once you do that, you can now apply the principle of double indices, meaning that is going to be 3 to the power 1 times 3 there, okay, over 2 to the power 1 times 3, which ultimately will give us 3 cubed over 2 cubed. 3 cubed will give you 27, 3 times 3 times 3 is 27, 2 to the power 3 is 8, and that will be your answer there. So that is that about double indices. You'll notice here there's also a question on double indices there. Okay, so I hope that is clear. There's a question actually I'm going to give you. I didn't add it to this question. It was something like 64 over 125 to the power negative 1 over 3. So here we had about how many indices? 3. Okay, we had negative indices, fractional indices, and double indices, because there are powers inside here. Okay, so I need you to convert this one to a positive, and then you apply the principle of fractional indices, and then you find your final answer. So yeah, expect something like this in your assignment, but I will also do a question that is very similar to that one. So that is that about double indices. Okay, at this point, let me show you now the next law of indices, which is any value raised to the power of 0 is equal to what? 1. Whether it is 1000, so long as it is raised to the power of 0, the final answer is a 1. Whether it is 99,999, when you just raise it to the power of 0, it becomes a what? A 1. That is a principle I want you to make sure you master. You can see here there's this number here, evaluate. It's raised to the power of 0. The examiner was just trying to test someone. Does this one know that any value raised to the power of 0 is 1? It is also appearing in this paper here. 2 to the power 0. Does this person know that any number raised to the power of 0 is 1? So for those who are curious, why is it a 1? This is why it is a 1. Let me explain. Okay. So let's say you have a to the power 3 divided by a to the power 3. So this one we are going to solve it using the algebraic fractional method, where we are going to expand. Remember we said the power shows you the repeated multiplication of a number by itself. So a to the power 3 simply tells us it is a times a times a, over, down here also have a times a times a. When you start dividing there, you realize that that a and that a will cancel. Now remember that a had an invisible 1, so when it is cancelled, the 1 appears. Even here the 1 appears. Okay, that a divided by that a, they cancel out. The 1 appears there, the 1 appears there. That one divided by that one, they cancel. That one appears there, and that one appears there. So meaning you are now going to remain with 1 times 1 times 1 on top, and then down here 1 times 1 times 1. 1 times 1 times 1 is 1, over 1 times 1 times 1, that is a 1. 1 divided by 1 is a 1. Okay, the same question, if you now solve it using the laws of indices, if we divide there, what are we going to get? We are going to say a to the power 3 minus a what? Minus a 3. We said when the variables are the same, you have to divide, you have to subtract the powers, right? So that's how we're saying 3 minus 3. Okay, that will give us a to the power 3 minus 3, it gives us a what? A 0. Now if you look at these two questions, this one here is the same as this one here. They both mean a to the power 3 divided by a to the power 3. Okay, but this one up here gave us a 1, while this one here has given us a 0 as a power, a to the power 0. That is why we say a to the power 0 is equal to 1. So that is that, for those who are curious. So at this point, all I need you to know is that no matter how weird the question looks, let me even give you a very nice leakage for the question I will give you in the assignment. You had something like this. Let's say you have 105 over 294. Okay, raise the power of 0. This whole expression, no matter how weird it looks, it is just 1. As simple as that. Don't even overthink anything here. Any value raised to the power of 0 is a 1. That's a shortcut. Okay, if you follow the longer route, it's going to be double indices there, right? 105 to the power 1 times the 0 outside, over 294 to the power 1 times the 0 there. Okay, that will give you 105 to the power 0, because 1 times 0 there is 0, over 294 to the power 0, because 1 times 0 there is 0. Then here we said any number raised to the power of 0 is 1, over any number raised to the power of 0 is 1. 1 divided by 1 is 1. That is why I said this whole expression will just give you a 1. So I need you to master that one, so that by the time we start solving, you'll be able to apply it. Okay, then we can now look at the next law, which is negative indices. So for this one, we're going to use the same expression as for division. So remember I told you to say, I only gave you examples where we were dividing from a bigger power to avoid getting negative indices. Okay, so now let's say this time around we are not so scared of negative indices. We approach this one like that. Before we look at this one, let me just recreate the meeting on the other side so that the other student can also join. Zoom has a limit per meeting. For the free version, you can only have a meeting that goes up to 40 minutes. Beyond that, you need to purchase the license or subscribe. So that's why every after 40 minutes I keep recreating a new meeting for the other students. Let me just share the link with them now. Okay, let me just share the screen now. Okay, we can now proceed. Let me just confirm that my mic is on the other side, because I'd actually forgotten to turn it on the other time. Okay, it's on. Alright, so remember I said the questions, the examples I gave you on division were those whereby you're just subtracting from a bigger power so that you don't end up with a negative power. But in this case, let's say we have something like this, meaning it's going to be 3 minus a 4. So that will now give us negative 1 there. 3 minus 4 is negative 1. That's going to be our answer. Same question, if you solve it using the algebraic fractional method, it simply means you're going to solve it this way. A times A times A over A times A times A times A. So a to the power 3 simply means A times A times A. A to the power 4 simply means A times A times A times A. If you now start cancelling out the values, you notice that that A and that A cancel. You remain with now the 1 becomes visible. Even here the 1 becomes visible. That A and that A cancel. The 1 becomes visible. Even there it becomes visible. That A and that A cancel. The 1 becomes visible, and here it becomes visible. Meaning down here we're going to remain with 1 times 1 times 1 on the numerator part, and then down here we're going to have 1 times 1 times 1 times A. 1 times 1 times 1 on top will give you a 1. 1 times 1 times 1 times A will give you A. Okay, same question solved differently has given us these two answers. Therefore, A to the power negative 1 is equal to 1 over A. Alright, now this is how I easily remember this. This question is, this topic is actually very important. You will meet it when you look at calculus. You find questions such as, for example, 4 over x squared, and you are asked to differentiate it. Okay, you are basically just dealing with negative indices there. Those of you who have already covered this topic, you will notice to say this is actually a question that involves negative indices as well. All right, so what is the easiest way you can remember this? So this is basically what I do personally to quickly remember that any value raised to the power of a negative term is supposed to be written this way. Okay, so when you have A to the power negative 1, in order for you to write it as a positive index, simply say this negative here simply means 1 over, and then your base comes down here, and then the power follows the base. What was the power? The power was negative 1. If it was A to the power negative 2, how are you going to rewrite it as a positive index? We said this negative simply means 1 over, and then the base goes down here, and the power follows the base. You notice now that the power has become a positive. So that is how you rewrite negative indices into positive indices. But when you go to calculus, you need to actually be doing the opposite. Okay, you have something like this. Like I mentioned, you have 4 over x squared. You now need to rewrite this one as a negative index before you differentiate or integrate. Okay, so how then do you do that? all you have to do is, let's say you have let me now use a different number. Let's say you have what is this one? Let's say you have 1 over 5 squared. How do you rewrite this one as a negative index? All you have to do is you take the 5 up here, and then the power becomes a negative. So here it's a positive, there the power has to become a negative. Now what if on top you have something like a 2 and then you have an x here, x to the power 3? How do you rewrite this one as a negative index? You already have the 2 there, so just write it there, and then you add an x, and then you change its power to a negative. That's how you rewrite a positive power as a negative power, and vice versa, just like that. Okay, so actually I even have a question, very interesting question on this one. Where did I see that question? Did I put it here? Should be here somewhere. I think I forgot to put, I said I'll give it to you as an assignment. Okay, nice. All right, so you expect something like that in the assignment. Remember, once that assignment is given to you, the questions you fail to answer, I'll still solve them for you. The goal for me is always to make sure that students are always learning. I don't like spoon feeding too much. I'll teach you everything you need to know, and then just leave a bit more for you to continue thinking. Because if what you have learned is what comes as an assignment, then learning doesn't take place there. You are just revising. Okay, so your assignment should be slightly different from the examples you looked at in class. And your homework should also be slightly different than the assignment you did in class. That is how learning should take place. People should continue thinking. That is why questions are always different. So those of you who are my students, you know this is what I always do. I'll give you a question, introduce you to something, then I'll give you something slightly different from what I gave you, or even different from what I gave you. The idea also is to make sure that I train you to attempt strange things, strange questions in the exam. Okay, I don't want people going into the exam room with an attitude of whatever they see which is strange to them, they leave it. No, sometimes you can find that the same question that looks strange, you figure it out. You leave the exam room, you check online, how do you solve this question, and then you actually find out that the same way you solved it is the correct way. So that is the attitude I want people to have as they enter the exam room. They should be able to attempt questions that look strange. So that is why I keep giving people different types of questions. What I teach you should be different to what I'm going to assign you as as an exercise or an assignment rather. Okay, so that is the goal that I run by. So we're done looking at negative indices. We now look at fractional indices. So what are fractional indices? Fractional indices are expressed using something like this: m over, okay, let me use r and p, r over a p. So you now notice that the base is a, and then the power is a fraction, r over p. That is your power. I'm sure you've seen these questions before. Okay, let's say for example 9 raised to the power of maybe 3 over 2, something like that. Evaluate in the exam papers. Okay, so how do you tackle such types of questions? So what you do is, the first thing is you are going to introduce a bracket there, then inside the bracket you're going to put a root. Okay, the p here, the bottom number, the denominator comes and sits here, and then your base goes inside the root. Okay, so your a will go there, that looks like a 9. Your a will go there, you close the bracket, and then the top number, which is the numerator, goes outside there. So if you're going back to that example I gave you, 3 over 2, it simply means you're going to open a bracket, you introduce a root. The denominator of the fraction there comes and sits there, your base comes here, you close the bracket, and then the top number goes outside as your power. That is how you actually convert the fractional indices to this format. Okay, I hope that is clear. Now, how do you solve these types of questions? Of course, we have converted them from this format to that format. Now, how do we actually solve them? So this is how we actually solve these questions. Okay, sometimes they'll come as a fraction or they'll come as already converted for you. I think I even have some examples here. Do I? Okay, I don't. Okay, so you can see here there is a fractional index there. Same applies to that one there. Okay, so let me now give you an example. Let's say you have 9 to the power 2 over, not 2 over 2, let me put 3 over 2. 3 over 2. So I said the first thing is open a bracket, introduce a root. The bottom number sits there, your base comes inside the root, and then you close, and then the numerator is a power. It goes outside the bracket. Once you do that, all you're asking yourself is what is the square root of 9? But then there are going to be times when you have maybe different numbers, maybe a 4 there or something. How are you going to solve it? Okay, so that is how I approach this question using this simple method, where I say here all you are looking for is a number that you can multiply by itself 2 times to give you a 9. So what number can you multiply by itself 2 times to give you a 9? You are going to start testing, starting with the smallest reasonable number, a 2. Okay, so you're going to say 2 times 2. Remember, we're saying what number can we multiply by itself 2 times to give us a 9? We test. What is 2 times 2? 2 times 2 gives me a what? A 4. So I know to say it is not a 2. I go to the next one, a 3. So you increment by 1. Okay, what is 3 times 3? 3 times 3 gives me a 9. Once you have identified that number then replaces this entire confusion you are seeing here. Okay, it will just be replaced by that 3, and then the power will drop to the 3. This power here, it drops here. That is all you have to do. And then at this point you simply simplify. What is 3 raised to the power of 3? 3 raised to the power of 3, remember I said, does not mean 3 times 3. It simply means 3 times 3 times 3. 3 times 3 here is 9. 9 times 3, 27. That will be your final answer. Okay, let me give you another example so that this can sink in. Okay, let's say you have another number like let's say 27. Okay, I want to use a different number. Let's say you have 64 raised to the power of okay, let's start with 4. Is it 4? Okay, let's should be 3. So let's say 2 over 3. Okay, so this is a formed question, a made up question. In case it is wrong, please realize that it is made up. I might have the powers wrong or they might be correct. So we said the first thing you do is you open a bracket, you introduce a root, and then the bottom number sits here, the base goes inside the root, you close, and then the top number is your power, it goes outside the bracket. And then you're going to ask yourself, what number can I multiply by itself 3 times to give me 64? I'll start trying. 2 times 2 times 2. What does this give me? 2 times 2 is a 4. 4 times 2 there is 8. I've noted that the 2 is not the number I'm looking for. I go to the next number, 3. 3 times 3 times 3. 3 times 3 there is a 9. 9 times the 3 there is 27. That is not the number. I go to the next one, 4. 4 times 4 times 4. What do I get? 4 times 4 gives me 16. 16 times 4, what do I get? 4 times 6 there is 24. Remember 2. 4 times 1 there is 4, plus that one is 64. So I've now figured to say the number I'm looking for is a 4. Therefore, the 4 will replace this whole confusion you are seeing here. You just write the 4, and then the power drops to the 4. Okay, then you simplify. What is 4 raised to the power of 2? 16, because 4 times 4 is 16. So that is how you solve these questions. Let us now look at exam questions, then we'll go to exponential equations. So this is now going to be a summary of all those laws we have looked at. We come to the first one. They are saying, so this question they usually say evaluate. Okay, negative 2 raised to the power of 0 times negative 2 raised to the power of negative 3. So for this one, we know to say any number raised to the power of 0 is what? is 1. So this will give us a 1 there. Then we're going to say times. Here there's a negative index. We need to convert it to a positive. What to do so you need to do? We said that negative simply means 1 over, and then your base here drops down here. So since there is a bracket there and there's a negative number inside, we're going to drop it like that as a bracket, and then the power drops to the base like that. So meaning it's going to be 1 times 1 over, what is negative 2 raised to the power of 3? Now please take note that this means negative 2 times negative 2 times negative 2. You see how strange that looks? Simply because we did not put brackets there. That is why brackets are important when you're dealing with negative numbers. So this simply means negative times this negative here, it gives you what? A positive. That positive you are going to get times this negative here, it should give you what? A negative. Therefore, negative 2 raised to the power of 3 will give you a negative at the end here as your answer. Okay, because in paper 1 you don't have a calculator, so apply that negative accordingly. So if we simplify there, we're going to say 1, okay, we can say 1 times 1 over negative 8, because negative 2 times negative 2, what does it give you? Gives me positive 4. Then I'll say positive 4 times negative 2. What does it give me? Positive times negative there is negative. 4 times 2, 8. That is a negative 8 you are seeing down here. At this point, we can now say over 1. We can now say 1 times 1 there is 1 over 1 times negative 8. It will give us negative 8. So that is your final answer right there, and you are done. As simple as that. The only thing the examiner did to confuse people here is add that negative power there, and then here they just wanted to check, does this person know that any number raised to the power of 0 is 1? Okay, so that is that, and you're done. We go to the next one. Evaluate 3 raised to the power of 2 plus 3 raised to the power of negative 1 times 2 to the power 0. Okay, so here this is an interesting question with several laws of indices. You have negative indices, you have 0 indices, and then you have this power here. So here you can simply say 3 raised to the power of 2, what does it give you? 9, not 6. 9. Then we're going to say plus. Here we have a negative index. What do? We need to rewrite it as a positive index. So we said that negative simply means 1 over, then the 3 drops down here, and then the power becomes a positive. Okay, from a negative. That is that. Then we're going to say times 2 to the power of 0 is just 1. Okay, so at this point, according to board mass, we multiply first. So meaning the answer is just going to be 1 over 3, because we can say over 1. So 1 times 1 is a 1. 3 times 1 is this 3 here. Okay, once we get here, we can now say, let me write the 9 as a smaller number, 9 over 1, and then we come up with a common denominator, which is a 3. We're now going to say 3 divided by 1 there is a 3. 3 times 9, that is 27. We bring down that plus. Then we're going to say again 3 divided by that 3 there is 1. 1 times 1, 1. Giving us what? 28 over a 3. Converted to a mixed fraction to be 28 divided by 3 is a 9. Remainder a 1 over the same denominator. So that should have been your final answer there if you are given such a question by me or the examiner. Okay, we are done. Remember the drill is, if you have a question, you can raise your hand, because I keep looking at the meeting. So if you have a question, raise your hand, or you can type in the chat, just like you have been doing. Okay, we proceed to the next one. Now here we have a fraction inside the bracket, and we also have a fraction as a power. Okay, so what we have is 8 over 27, like that, and then to the power 2 over a 3. So how do you apply that fractional law of indices? We said whenever you have a fraction, you need to what? Introduce a root. you introduce a bracket, and then you introduce a root inside the bracket. So all you have to do is you plug in these two numbers, the same fraction, like that, and then you close. So we said the bottom number sits there, and then the top number is your power, so the power comes outside. Okay, I feel like I should write it from down here, so allow me to use a square bracket. Okay, you introduce your roots there like that. The bottom number is a 3, it comes there. Inside the brackets you have 8 over 27. You close the bracket, and then the 2 goes outside. You have properly applied the law of fractional indices. At this point, you are going to ask yourself, what number can I multiply by itself 3 times to give me 8? Again, what number can I multiply by itself 3 times to give you 27? So we start testing. 2 times 2 times 2, what do we get? 2 times 2 is 4, 4 times 2 is 8. So we know to say on the top here, for the numerator, the top number is a 2. Over, we go to the bottom number. We've already tested for a 2, so we can simply progress to the next one. What is 3 times 3 times 3? 3 times 3 is 9, 3 times 9 is 27. So I've identified that number, so you put your 3 there, and then you close the brackets. You also open this side, and then that 2, this one here, drops down there to those numbers. And then you apply the law of double indices. That simply means it's going to be 2 to the power 1 times 2 outside there, over 3 to the power 1 times 2. Okay, there's a 1 here, remember, there's also a 1 there. So 1 times 2, 1 times 2 there. Okay, once you do that, then you can finalize by saying 2 squared over 3 squared, giving you 4 over 9. 2 squared is 4, 3 squared is 9. And you are done. As simple as that. Remember, if you have a question, raise your hand or type in the chat. We proceed to the next one. Okay, I'm going to give you another example where you have a negative power, because that one is coming as an assignment. So I'm going to say here we have 8 over 27 to the power 1 over 3. We said when you have something like this, you need to open the bracket, introduce a root. So you introduce a bigger one here since you have a fraction inside the bracket. Okay, the bottom number sits there. Inside you also put that fraction. Okay, and then you have a 1 there. Let me look at the previous question. You've seen the similarities. There's 8 over 27, 8 over 27 here as well. This one came in 2024. 2024 GCE. This one came in 2023 paper 1. You see how simple maths is. Math is actually the only subject where you can walk into the exam knowing that I've gotten a distinction 1. Why? Because you have prepared adequately. You have gone through exam papers. You have identified the format. You know how questions come. It is possible. It's different from these other subjects that have notes, because the notes are vast. They can bring the exam from anywhere. But mathematics, it's the same. You can see all these questions. These are different exam papers, but just evaluate, evaluate, evaluate. And you know this is all falling under indices. So if you know the entire topic for indices, you are ready for that exam. Okay? Now, being excited, we've even deleted the question before we finished answering. Okay? So here we have what number can you multiply by itself? We already found that number. So it's 2 over 3 as our final answer there. Raise the power of 1 if you like. Okay? Meaning it's going to be 2 1 times 1 over 3 1 times 1, giving you 2 to the power 1 over 3 to the power 1, which is the same as 2 over 3. Okay, I've rushed through this one because it's the same values we are dealing with in the previous question. So we're done with these types of laws of indices. Now we go to exponential equations. So exponential equations are these types of equations where you are asked to solve the equation. Sometimes they'll say given that something like that, then find the value of x, and then sometimes they'll just say solve the equation. Okay, I only gave you one here. No, I need about 2. Let me fetch another one. Okay, as I'm fetching another question, could there be a question? we are pretty much done with indices. We are winding up indices. Next one is arithmetic progression. So could there be any question, any clarity, or maybe vonse panga chesensi up? If we are all good, then that's nice. Okay, let me add this one. Okay, let me add this one for you also, so that I can explain what I was trying to talk about on the other side. Okay, I know what to give you now. There's another nice question I can give you. Let me use this nice one here as an example, and let me also add a last one, which is going to be this one here. Okay, yeah, let's have a couple of examples under exponential equations as well. Okay, there seems to be no question. Okay, great. We now go to the exponential equations. So now, what are exponential equations? Exponential equations, so these are actually in two formats, although they don't like bringing the other one because it's too simple. The other one is where, so these are basically types of indices. These are basically equations involving indices. You've noticed here there is these are powers. You have these strange powers here, x minus 1. Okay, you have this strange power here, x plus 3, and then you have this one here, negative 3 to the power 5 to the power negative 3x. These are called exponential equations. So under equations involving indices, you have two formats. Okay, it's either you have something like 2 to the power x is equal to 4, or you could have x to the power 2 is equal to 2, or no, 4. Let me put a 4 there. Okay, you could have one where the unknown value is represented by x. You could have one where the unknown value is on the power side or it's on the side of the base. This is the one they don't like bringing because it's very simple compared to the other one. Okay, this other one they can mix it up like this one here, make it look strange. That's why they like, if you check through the majority of papers from 2017 or rather 2016 to 2025, these are the types of equations you're going to find involving indices. They like these exponential equations because these are seemingly tougher than these ones. These ones are very simple. Okay, so these are the ones I'm going to cover. So here's a principle. Whenever you're dealing with an exponential equation, when the unknown value is on the power side, your goal should be to make sure that the bases, you remember bases, right? We said x to the power 2, x is a base, 2 is a power. Okay, therefore here 2 to the power x, 2 is a base, x is a power. Okay, so the goal is to make sure that the bases on both sides of the equal sign, on the left and on the right, should be the same. That should be your goal, your first step. And you have to make sure that you use the smallest base possible. Okay, so meaning here, this is the smallest base possible. We can't reduce this number. Okay, remember when we are looking at difference of two squares, 9 could be expressed as a base like this, 3 squared, right? 4 can be expressed like this, 2 squared. Because 2 squared is the same as 4, not so. 2 times 2 is 4. 3 times 3 is what? 9. But a 2, you can't express it as an index, and it should mean the same as this value here. So you make sure that the bases should be simplified. By simplified, I mean they should be expressed using the smallest base possible. So I mean here we've already determined that the 2 is the right base. So I'm just going to say 2x And then we said the goal should be to make sure that the bases on both sides of the equal sign are the same. So meaning now kutifaka equal 2. Then now your question should be, what is the power now here? What power should I put? So all you have to do is simply ask yourself, how many times should I multiply this 2 by itself to give me a 4? You will notice that you can only do that twice. When you say 2 times 2, that will give you a what? A 4. Once you have achieved that, it simply means you are done. Once the bases are the same, like this, you now focus on the powers. Okay? You equate these powers, meaning your final answer is just going to be x is equal to 2. That's how you solve these exponential equations. Let me give you another example. Okay, I want by the time we're going to the exam questions, at least we're good to go. Let's say 3 to the power 2x is equal to 9. Okay, so we've noticed to say this is the smallest base possible for 3. Okay, so we're just going to say 3 to the power 2x. What is our goal? To make sure that we have the same base both on the left and on the right side of the equal sign. So ukuna kwa ufunga 3. Now it's up to you to figure out the power. What power should I put? So I'm just going to ask yourself, how many times can I multiply this 3 by itself to give me a 9? It is 2 times. So the 2 there becomes your base, your power I mean. Once the bases are the same, like you have noticed, you now focus on the powers. You equate the powers. So it's going to be 2x on the left side is equal to 2 on the right side. Then you solve for x. So you just divide by 2 by 2. Here the 2's will cancel, meaning your x is going to be equal to what? 1. Because 2 divided by 2 is 1. And you are done. Okay? There are other scenarios where you have something like, let's say you have a 4 raised to the power of negative x. Let me put this one. Okay? Is equal to 16. Your goal is to make sure that on both sides of the equal sign, you have the same bases, right? Simplified bases. You notice to say this 4 can be simplified. How can you simplify the 4? You know to say 4 is the same as 2 squared. Because 2 squared is 2 times 2, giving you a 4. So we are going to simplify that 4 by using the smallest base possible. So it's going to be 2 to the power 2. But remember, there's already a power here. So what do you do to that power? You are going to put it in brackets, negative x there. So when the power is already there and you've simplified, those powers, the new powers should now multiply. Okay? So meaning here you are going to say 2. Remember, your goal is to make sure that the bases on both sides of the equal sign are the same. Now we need to figure out what power to put here. So how do we do that? We are going to say, how many times can we multiply this 2 by itself to give us a 16 there? We start testing. 2 times 2 times 2, I know it gives me 8. From the previous lessons, if I add another 2, it gives me 16. So I count how many 2's have I used? 1, 2, 3, 4. So meaning my power there is what? 4. So in other words, what you have down here, okay, should mean the same as what you have up there. 2 to the power 4, when you expand it, will give you 16. 2 to the power 2 here, when you expand it, it will give you a 4. Okay, so that is your goal. Now that we have simplified the bases on both sides of the equal sign and they are the same, we can now focus on what? The powers. But before we do that, we need to expand here. So we're going to say 2 to the power, this is a positive. Positive 2 times negative x, that will give us negative 2x, which is equal to 2 to the power 4. Okay, when the bases are the same, you equate the powers. So negative 2x is equal to 4. We solve for x by dividing by negative 2 on both sides. So there they will cancel, the 2's will cancel, meaning your x will just be equal to, there's a positive here, remember. So it's positive divided by negative, giving me a negative. 4 divided by 2 there, giving me a 2. So x is equal to negative 2 and you are done. So far, we are ready to answer exam questions. Do we have any questions before I conclude? Okay, great. Let us now look at question 1. So question 1 says 8 to the power x minus 1 is equal to 16. Okay, remember you have to simplify the bases. How can you simplify this to? What number can you use to simplify it? Okay, so usually that number you use to simplify is a common factor for both of these numbers. These numbers are always strategically placed. So maybe you could even say, what is the smallest, most reasonable common factor for these two numbers I have? Except one, of course. Or you can say the next smallest common factor for the numbers I'm dealing with. That is a 2, right? Then you ask yourself, how many times can I multiply this 2 by itself to give me 8? It is 3 times, because 2 times 2 times 2. 2 times 2 is a 4. 4 times 2, 8. Okay, we have achieved that. But remember, there's already a power there. So that power, you need to put it in brackets, like that. And then you say equals. You have already determined that you should have 2's on both sides of the equal sign. So now, how many times can you multiply this 2 by itself to give us 16? It is 4 times. Okay, we're just from testing. 2 times 2 times 2 is 8. Okay, times 2, that is 16. Okay, so now we need to expand on the left side. So we're going to say 3 times x is 3x. Again, 3 times negative 1, that is negative 3. And then we say equals to 2 to the power 4. The bases are the same. We have achieved this. So now we equate the powers like that. So meaning we're going to say 3x minus 3 is equal to what? 4. Then you solve for x. So you're going to say 4 over, not 4 over something, 4 plus 3 actually. This is negative 3. When it crosses, it becomes positive 3. What do you get there? 3x is equal to 4 plus 3, 7. We divide both sides by 3. By 3. There they cancel. Okay, what do you remain with? X will be equal to 3 into 7 is 2. Remember, 1 over 3. That is the value of x, and you are done. Do you have any questions? No questions, I presume. So for this one, allow me to start with this one before we go to this strange one here. Okay, so we're now going to say 5 to the power negative 3 over x is equal to 125. Okay, so here 5 is an odd number. You can't express it in any other way. There's no common factor other than 1 we can use to express 5 as an index. So we have determined that 5 ilicheo kusaidu. We can't simplify it any further. But 25, okay, remember the bases are supposed to be the same. So once you find the smallest base, that means that is what you're supposed to put on the right as well. So 5, how many times can you multiply 5 by itself to give us 125? You start testing. 5 times 5, what does it give me? It gives you 25. Okay, 25 times 5. 5 times 5, you know it's 25. Remember 2. 5 times 2 is 10. Plus that 2, 12. That gives you your target number. Then you count how many 5s have I used. 1 there, 2 there, 3 there. Okay, so meaning my power is what? 3. Once the powers are the same on both sides of the equal sign, you now equate the what? The powers. So meaning it's going to be negative 3x is equal to a 3. You solve for x, you divide both sides by negative 3. By negative 3, here those will cancel. You just remain with x. Then here there's a positive. So positive divided by negative, there is negative 3 divided by 3. That gives you a negative 1 as your final answer. And you're done. We now go to the last question on fractional indices or exponential equations, which is 2 to the power x plus 3 is equal to 1 over 16. Now, on the left side, we have determined that this is the smallest base possible, but on the right side, we have a fraction. What is this we're looking at? Okay, all we have to do here is we convert this fraction or this positive index to a negative index. Remember, we said when you have something like this, 1 over, let's say, 2 to the power negative 3. Okay, let me use a variable. X to the power negative 2 is the same as 1 over x squared. So this is the same as what you are looking at there. So all you have to do is convert this one to its negative version, like this one here. So what did I say we do here? I gave you a tip, and I wanted you to do this as an assignment, but I'm being nice. So we're going to say, we said this 16 just goes up here, and then the power becomes a negative. Okay, remember, if you can't see the power, then it's a 1. So that's how come the power has become negative 1. That is the right thing to do there. Once you have done that, you can now say, what's the common factor for 2 and 16 other than 1? The smallest, it's a 2. So that's your smallest base there again. So how many times can you multiply this 2 by itself to give you a 16? We already determined in the previous question that it is a 4. But remember, there's already a power there, negative 1. So you need to put it in brackets. And then simplify. So 2 to the power x plus 3 will be equal to 2 to the power negative 4. Because 4 times negative 1 is negative 4. Once you have found that, you can now, you have attained that, you have managed to make the bases the same on both sides of the equal sign. So at this point, simply equate the powers. So I'm going to say x plus 3, the power on the left, is equal to negative 4, the power on the right. Then solve for x. So meaning it's going to be x is equal to what? Negative 4 minus a 3. X will be equal to negative 7. Why? Because we said when the powers are the same, you maintain the same, not the power. When the signs are the same, you maintain the same sign, and then you add the numbers. 4 plus 3 giving you negative 7. And we are done with the indices. Do we have any questions? Have we understood? Have people understood? Or people are confused? If you have understood, you can give me a positive reaction. Okay, great. I can see some of you have responded. Okay, nice. Okay, it's good that people have understood. So we are done looking at indices. We are now down to the last topic, which is arithmetic progression. So this is now 2313. So for this one, I'll give you 7 minutes break so that we can start at exactly 23:20. 40 minutes is enough for us to look at this topic. Okay, so you can go for a break. You can do what you can to make sure you stay awake. Me, I'm very awake. I remember the time I was going to write mathematics, I solved the whole night. I slept after writing the paper. Okay, but I'm not saying you should do that, because we have different limits. Some of us, if we stay up the whole night in the exam, we can't function properly. So now is your time to figure yourself out. If I study up to 24 hours, can I still be function at 8 hours? If you can be, then study up to that time. If I study up to 03 and then I wake up at 8 hours, do I still function properly? Like, am I able to process information properly? If you can, then by all means do that to make sure that you get the best. There are also those people who don't like studying before an exam, because when they study they forget. So we are different as a people. Figure out what works for you. What works for me may not work for you. But now is the time for you to figure out. How long do you last when it comes to studying? To a point whereby the next day you'll be functional, you're ready to write an exam. Now is the time for you to figure out. Don't start experimenting. My Romendo Remba, you say, no, I'll gun the whole night. Then in the morning, you are just confused because you've not had enough rest. So now is the time for you to figure out. You can do an experiment. If I study from maybe 23 or maybe 22 up to 04, then I sleep for 3 hours. Will I still be functional? I sleep for 2 hours. Will I still be functional? Or if I stay up the whole night, will I still be functional to a point whereby I can write proper values? Because when you're tired, the brain starts malfunctioning. Instead of writing a 2, in your mind, I want to write a 2, but you end up writing a 3 or a different one. Instead of writing -2, you write negative. Maybe you say +2. That is when you are tired, like extremely tired. So now is the time for you to experiment what works for you. Because I know the time you guys will be writing, I'll do an all-night revision. So I don't want to disadvantage people whereby we solve with them the whole night, then the following day they fail to write. So please figure out what works for you. So we have 5 more minutes remaining. I'll be back in 5.